Welcome back, deep divers.
Right.
Today, we're going to take a trip back in time,
Oh, boy.
all the way back to, like, 3.26 billion years ago.
Wow, like that.
During the Archean eon. So, picture Earth.
Okay.
This is crazy volcanic landscape,
Mm-hmm.
you know, lava everywhere, oceans,
Yeah.
just teeming with these, like, single-celled organisms, right?
Yeah, that's when life was just getting started.
Just starting out.
Yeah.
And we're about to witness a meteorite impact
Okay.
that's going to, like, totally dwarf the one that
Yeah.
wiped out the dinosaurs.
Oh, wow.
Right.
Okay.
Yeah.
Bigger than the Chicxulub impact, huh?
Way bigger.
Okay.
Yeah. So the Chicxulub impact,
Right.
I mean, that was a big one, right?
It was massive.
But this one,
yeah.
this one's called the S2 impact.
S2.
Yeah, and it was caused by this meteorite.
Okay.
Like, get this.
Yeah.
It was the size of, like, 4 Mount Everest
For Mount Everest.
slamming into the earth.
Oh, my God.
Yeah, 4 Mount Everest.
I'm trying to even picture that.
It's, like, unimaginable.
Yeah, that's incredible. So, I mean, what happened? I mean, did it just obliterate everything?
I mean, it definitely caused, like, some serious mayhem.
yeah.
So the sources for this deep dive,
Okay.
there's a new study from the Proceedings of the National Academy of Sciences.
Right. We saw that one.
And also some articles from Science Daily
Okay.
and the Harvard Gazette.
Gotcha.
And they all, like, describe it as kind of like this complete
You
reshuffling
were shuffling.
of, like, the deck for life on Earth.
So like a reset button almost.
Yeah, kind of like a reset button.
Wow.
So reshuffling the deck, how so?
So picture yourself like on the coast of
Okay.
what we now call Cape Cod, right?
Sure.
And you're just hanging out in the shallow water.
All right.
But keep in mind, there's no trees or anything yet.
Oh, right.
So the coastline would have looked really different.
I hadn't thought about that.
Yeah, and suddenly this mega tsunami just comes roaring in.
Oh, my God.
Not just any tsunami, though.
Okay.
This thing's powerful enough to scour the ocean floor
What?
and fling debris miles inland.
Oh, man.
Yeah.
I'm guessing this wasn't a good day to be a single-celled organism, right?
It was definitely a trial by fire, or I guess I should say a trial by boiling water,
Oh, right.
because the heat from the impact was so intense.
Yeah.
It literally boiled away the top layer of the ocean.
Oh, my God.
Yeah, and then on top of that, you've got the atmosphere.
Yeah.
It's choked with dust and debris,
Oh, man.
blocking out the sun, plunging the planet into darkness.
So, like, no photosynthesis.
It's like a synthesis, yeah.
Which, like, pretty much all the organisms were.
Right, exactly, relying on, right.
That was their primary way of getting energy.
Yeah.
So, yeah, put on hold.
Man, it sounds like a recipe for,
Yeah.
total annihilation.
Yeah, it sounds pretty bleak, right?
Yeah, but
Yeah.
there's a silver lining.
Really?
Yeah,
Okay.
and it kind of challenges the way we normally think about
Yeah.
catastrophic events,
Okay.
Yeah, so while the S2 impact was definitely devastating,
Right.
it also created these opportunities for certain life forms to, flourish.
Oh, wow.
Yeah, and that's where things get really interesting.
Okay, so who were these, like, unlikely survivors?
Well, they're called iron-metabolizing bacteria.
Iron metabolizing.
Yeah, I know, it's a mouthful.
It is.
But before you, completely tune out...
I'm listening.
Okay, good.
Yeah.
Let me explain.
Okay.
So these bacteria, they don't need sunlight like plants do.
Okay.
Instead, they get their energy from
Oh.
chemical reactions involving iron.
Oh, okay.
Yeah, it's kind of like how we get energy from food.
Oh, interesting.
Yeah,
So they're like the ultimate survivors, huh?
exactly. Yeah.
Thriving in conditions that would just, like,
Totally wipe out.
wipe out most other life.
Yeah, most other life. Yeah. Yeah. And here's where that mega tsunami we talked about,
Yeah.
it plays a crucial role.
Okay.
It dredged up massive amounts of iron
From
the ocean depths,
Oh, okay.
bringing it up to the surface
Yeah.
where these bacteria could access it.
Wow. So the impact created this, like, iron feast for these bacteria.
Yeah, you could say that.
That's crazy. It's like turning lemons into lemonade
Yeah.
on a planetary scale.
Very dramatic, but yeah,
Yeah.
it's a good way to put it.
So wait, you're saying this one meteorite strike could have actually, like, helped life on Earth?
That's what the research suggests. Yeah.
I mean, that kind of goes against, like,
I know, right?
everything we usually think about impacts.
Yeah, it's pretty counterintuitive.
Yeah.
But that's what makes this research so exciting,
Yeah.
It challenges our assumptions about what we think of as a catastrophe
Right.
in the grand scheme of things.
Yeah, yeah.
And it suggests that even these seemingly destructive events, they can have these unexpected consequences
Right.
that like totally reshape ecosystems
Yeah.
and create opportunities for new life to emerge.
This is like blowing my mind. It's
Yeah.
like the impact hit this like giant reset button
Yeah,
and gave certain life forms a chance to like take center stage.
exactly.
But how do we even know all this?
Right.
I mean, it's not like there were,
Right.
scientists around 3.26 billion years ago
Yeah, no eyewitness.
to like document it.
No, but thankfully we have the geological record.
Oh, right.
Rocks,
Yeah.
they hold the secrets of our planet's past.
Oh, that's cool.
And that's where Dr. Naja Dreban
Okay.
and her team at Harvard come in.
Okay.
They've been meticulously analyzing
Okay.
rock samples from a site in South Africa
Oh, wow.
called the Barberton Greenstone Belt.
Barberton Greenstone Belt. Okay, so
Yeah.
these rocks are like time capsules
Exactly.
holding clues to what happened
Yeah.
billions of years ago.
Billions of years ago, yeah.
So what kind of clues are we talking about here?
So think of it like detective work,
Okay.
but on a like geological scale.
Okay.
Dr. Dreban and her team, they're looking for specific layers of sediment, chemical signatures,
Right.
even microscopic traces of ancient life
Wow.
preserved in these rocks.
That's so cool.
It's incredibly detailed,
Yeah.
but it allows them to like piece together this remarkably complete picture
Wow.
of what happened during and after the S2 impact.
So how'd they connect the dots between
Yeah.
this massive impact and the rise of these,
Right,
iron-loving bacteria?
right. So that's where we'll really dive deep in the next part.
Okay.
Trust me, you won't want to miss it.
Okay.
Yeah.
I can't wait.
All right.
That's
thanks.
good.
Yeah,
So,
cool. Okay, so these rock whisperers.
Rock whisperers. I like that.
Yeah.
Yeah.
What did they actually find? Right.
That like points to this whole iron bacteria takeover.
Okay, so they use like a bunch of high-tech tools and
Yeah.
techniques and stuff. But think of it this way.
Okay.
They're looking for clues,
Uh-huh.
just like detectives at a crime scene.
Right.
Only this crime scene is like billions of years old.
Right. Right. Yeah.
Yeah.
Okay. So what were the like
So
the smoking guns?
One of the key things they look for are
Yeah.
the different layers of sediment in the rock.
Okay.
Imagine like a layer cake, right?
Right.
Each layer represents a different period of time,
Okay.
and a sudden shift in the type of sediment
Yeah.
can tell you a lot about what was happening at that time.
So like if they see a layer of, I don't know, like sand
Mhm.
sandwiched between layers of mud, that could indicate like a sudden event, like a flood.
Yeah, like a flood or in this case a mega tsunami.
Right. Right.
Yeah.
And remember how we talked about
Right.
the impact dredging up iron from the ocean depths?
Exactly. Yeah.
They could actually see evidence of that
Yeah.
in the rock.
In the rocks, yeah.
Right.
They found layers that show a like a spike
Yeah.
in iron content dating back to the time of the S2 impact.
Wow. It's amazing that something as dramatic as a meteorite impact can leave such a like clear fingerprint
I know, it's pretty amazing.
in the rocks.
Yeah.
But what about the bacteria themselves? Are there like actual fossils
Yeah.
of these iron metabolizing bacteria?
It's tricky because we're talking about right, single-celled organism.
Tiny.
Incredibly tiny. Yeah.
Yeah.
Fossilized bacteria are they're pretty rare
Okay.
and often microscopic.
Okay.
But here's where it gets even more interesting.
Okay.
Scientists have developed ways to detect the
Okay.
chemical traces that these ancient bacteria left behind.
So they're like bacterial ghost hunters.
Yeah, kind of, yeah.
What do these chemical traces tell them?
It's all about metabolism.
Okay.
You see, different bacteria use different
Yeah.
pathways to get their energy.
Right.
And these different metabolic pathways can leave distinct
Yeah.
chemical signatures in the rocks.
So even if they can't see the actual bacteria fossils,
Right.
they can detect like the ghostly fingerprints
Yeah.
of their metabolism.
Exactly. Yeah.
That's incredible.
It's like finding a fingerprint at a crime scene, right?
Right.
It doesn't tell you everything about the person who left it,
Yeah.
but it gives you crucial information.
Yeah.
And in this case, those chemical fingerprints point to
Sure.
a significant increase in iron-metabolizing bacteria after the S2 impact.
It's like putting together this giant puzzle,
Yeah.
using these clues from the rocks
Right.
to like paint a picture of what life was like
Exactly.
billions of years ago.
That's a great analogy.
Yeah.
And the picture that emerges is one of resilience
Right.
and adaptation.
Yeah.
Despite the devastation of the S2 impact, life found a way.
Yeah.
Not only to survive,
Yeah.
but to thrive in the changed environment.
It really makes you wonder about the power of like
It does, doesn't it?
evolution and how life can like
Yeah.
bounce back from even the most extreme challenges.
Absolutely. And it highlights,
Yeah.
a key concept
Yeah.
in evolutionary biology,
Okay.
creative destruction.
Creative destruction.
Yes.
Okay. Sometimes, what seems like an ending
Right.
is actually the beginning of something new
Right.
and potentially even more complex.
Yeah.
The S2 impact may have, wiped out
Yeah.
many life forms,
Yeah.
but it also created the conditions for new ones
Yeah.
to emerge and diversify.
That's like nature's way of hitting the reset button.
Exactly. Yeah.
Shuffling the deck.
And dealing out a whole new hand.
Dealing out a whole new hand. Yeah, I like that.
Yeah.
And it's not just meteor impacts, right?
All right.
I mean, think about
Yeah.
volcanic eruptions,
Yeah.
ice ages,
Yeah.
even the rise of oxygen in the atmosphere.
Right.
These were all, dramatic events
Yeah.
that likely caused mass extinctions,
Right.
but they also opened up new ecological niches
Yeah.
and spurred evolutionary innovation.
So it's like this constant cycle of destruction and creation
Exactly.
with life constantly adapting and evolving
Yeah.
in response to these changes.
Precisely. And the S2 impact provides a compelling example of
Yeah.
how this process has shaped the history of life on Earth.
It's really mind-boggling to think about
I know.
like the vastness of geologic time
Yeah.
and all the like dramatic events that have like shaped our planet.
It is humbling, isn't it? It makes you realize that the world we see today is just a snapshot in a much longer and more complex story.
A story that's still being written.
Exactly. And each new discovery, like the one about the S2 impact,
Right.
adds another chapter to that story, deepening our understanding of the interconnectedness of life and a planet we call home.
This deep dive has definitely given me like a whole new perspective on things.
I'm glad to hear that.
It's like looking through a telescope
Yeah.
at the distant past, only to realize that it's also a mirror, like reflecting back on our present and our future.
Well said. And speaking of the present and the future, Dr. Draven and her team aren't stopping with the S2 impact. They found evidence of at least 8 major impact events preserved.
Oh my God.
In the Barberton Greenstone Belt.
8. So there's like even more stories
There's a lot more to uncover.
that's waiting to be like uncovered.
Absolutely. And each one has the potential to further rewrite our understanding of how life has evolved on Earth.
That's incredible.
So stay tuned because the deep dive is far from over.
I can't wait. 8 major impact events.
At least 8, yeah.
In just one location.
It's pretty